Okay. If this is the direction of the electric field, what will happen to the electrons? What will happen to the electrons? Motion of the electrons inside the conductor. Inside the conductor, the electrons will move in opposite direction of electric field. Right? Electrons will move in the opposite direction of electric field. And at that time, the electrons will get a drift velocity, Okay, that average velocity acquired by these electrons in the presence of electric field is called drift velocity. So what is drift velocity? Drift velocity is the average velocity acquired by the electrons. Average velocity acquired by the electrons in the presence of an electric field. In the presence of an electric field is called drift velocity. So you have to define what is drift velocity in that question. Then figure shows variation of the drift velocity of electrons in two copper wires A and B of different lengths versus the potential difference V applied across their ends. Right? What does the slope of the line represent? What does the slope of the line represent? That is the question. Okay. I will try to solve that question. There is a graph in the question. Right? There is a graph in the question. In that graph, on the y-axis, you have a drift velocity. On the y-axis, you have a drift velocity. And on the x-axis, you have voltage or potential. On the x-axis, you have voltage or potential. And there is two graphs, two lines. The first line is A. The second line is B. First line is A. And the second line is B. Now, the first line has greater slope. And the second line has lesser slope. So, we need to find what does the slope of the line represent. What is the slope of the line represent? What is slope? How can you find the slope? Slope is tan theta. Slope of a graph is tan theta. Always it is tan theta. What is slope? I will write the equation of slope here. Slope is y by x. Always. Slope is y by x. What will be y here? Y here is, we are writing the slope. Y here is a drift velocity. Here the y is drift velocity divided by, what is x here? Here x is voltage. Okay? Y is drift velocity and x is voltage in this graph. Y is drift velocity and x is voltage. Did you get it? Okay, now what is this drift velocity divided by voltage means? We haven't encountered such an equation until now. But we know the equation of drift velocity. What is the equation of drift velocity? VD. VD has this equation minus means the velocity of electrons are opposite of electric field. That's all. I'm just considering the magnitude of drift velocity. E by n tau. This is the equation for drift velocity. In this equation, there is no voltage. But we know another equation for electric field. What is the equation for electric field? That's voltage divided by distance. Voltage divided by distance is an equation for electric field. So you can apply that equation here. VD is equal to E into, instead of electric field, you can write V by L, tau, M. Now you have such an equation. For drift velocity. In this equation, you can see V. V is what? V is voltage. Right? V is voltage. If you bring the voltage to the other side of the equation, you will get VD divided by V. What is that? BD divided by B. BD divided by B is E tau by ML. What is that? That is E tau by ML. So this BD by B is now, the BD by B is now the slope. So slope is equal to what? Slope is equal to E tau by ML. Slope now is equal to E tau by ML. What is the slope here? Slope here is BD by B. From the equation, we got what is slope. This is slope. So now slope is equal to E tau by ML. Did you understand that? Did you understand that? Sidra, Jumana, did you guys understand that one? What is the slope of that question? Slope of the graph?
Yes, sir.
Okay. What about you, Jumana? Okay, Jumana. Okay, then that was the first question. And now the second one. Which one of the two wires is longer? Which one of the two wires is longer? Which wire is longer? Which wire is longer? Can you see any relation between slope and length? Slope and length. This is the slope, right? BD by B is the slope. So slope is equal to E tau by ML. In that equation, E is the charge of an electron, tau is the relaxation time, M is the mass of the electron. So this is a constant, but the length is changing, right? That means the slope will be inversely proportional to length. What is the meaning of that? Slope will be inversely proportional to length. Slope will be inversely proportional to length. You got it? Slope will be inversely proportional to length. Slope is now inversely proportional to length. Okay? If the slope increases, length decreases. Slope increases, length decreases. Who has greater slope in this graph? A or B? Which has greater slope in this graph? Which has greater slope? You have A and B. Which has greater slope? Tell me. Tell me, guys. Jumana, Sidra, which has greater slope in this graph? A or B? Yeah. A has greater slope. A has greater slope. The slope of A is greater. The slope of A is greater. Okay? Slope of A is greater. So, slope of A. Slope of A is greater than slope of B. Slope of A is greater than slope of B. You got it? Slope of A is greater than slope of B. And slope is inversely proportional to length. So, length of A will be less than length of B. Right? Slope of A is greater than slope of B. And slope is inversely proportional to length. So, length of A will be less than length of B. Length of A will be less than length of B. So, which has the greater length? Which wire has the greater length? The wire A. The wire A has the greater length. Did you understand that? Wire A has the greater length. You got it? Hi, Joseph. Joseph, we are discussing previous year question booklet. We are currently on question number 20. Is that okay, Joseph?
Yes, sir.
Okay. Question number 20. This is question number 20. Do you have the question booklet with you? Previous year question booklet?
No, sir.
You have collected question booklet from office, right?
Sir, is it in there?
Huh?
Is it in that?
A booklet, a book containing
Yes, sir. Yes, sir.
previous year questions. Do you remember that?
Yes, sir.
Do you have
I'll
that?
go get it. I'll go get it.
Oh, okay. Okay, did you understand this question? Jumana, Sidra? Okay, what about you, Sidra? Okay, okay. When you are back, just let me know, Joseph. I will explain this question again. Okay. Now, question number 21. Question number 21. Question number 21. The thickness of a conductor continuously decreases from its one end A to another end B. So, thickness of a conductor is decreasing from one end A to other end B. So, this conductor has two ends A and B. And thickness of the conductor at A is greater and that of at B is lesser. That is in the question. It is connected across the terminals of a battery. Now it is connected across the terminals of a battery. It is connected across the terminals of a battery. What will be the effect on the value of some quantities? What will be the effect of some values of electric field? First, electric field. What will happen to electric field? That is the first question. And second one, what will happen to current density? Current density. What will happen to current density? And the third one, mobility. What will happen to mobility as we are going from A to B? Okay, as we are going from A to B, what will happen to mobility? Okay, that is the question. That is the question. Joseph, are you back?
Yes, sir.
Yeah, okay, Joseph. I will just explain the previous question. I will just explain the previous question. That is question number 20. Question number 20. Can you see the question number 20? Current electricity. We are discussing the chapter current electricity. Current electricity. Did you find the question number 20?
Yes, sir.
Okay. In that question, the first part of the question is to define drift velocity. What is drift velocity? If you have placed a conductor without connecting that into a voltage, the average velocity of free electrons in that conductor will be zero because the free electrons will be in a random motion. Then average velocity will be zero. If you have connected that conductor to a cell, to a battery, then due to that electric field, the electrons will be moving in a particular direction. The electrons will move in a direction opposite to the electric field. The electrons will move in a direction opposite to the electric field. Then that electrons will get an average velocity. That average velocity is called the drift velocity. So what is drift velocity? Drift velocity is the average velocity acquired by the electrons in the presence of an electric field. What is drift velocity? Average velocity acquired by the electrons in the presence of an electric field. You got it?
Yes, sir.
Yeah, we have studied that. And in the second part of the question, you have given a graph. In that graph, on the y-axis, you can see drift velocity. On the x-axis, you have voltage or potential difference. And there is two graphs, A and B. A is of greater slope, B is of lesser slope. In the first question, first part of the question, they are asking, what does the slope of the graph represent? What does the slope of the graph represent? What is the slope of the graph represent? Slope is always y by x. What is slope? Slope is always y by x. This is y and this is x. Y by x. What is y here? Y here is a drift velocity. And what is x here? X here is a voltage. So what is slope? Slope will be drift velocity divided by voltage. What is slope? That's drift velocity divided by voltage. And we can find that from the equation of drift velocity. What is the equation of drift velocity? E by m tau is the equation for drift velocity. And we have the equation for electric field. This is the equation for electric field. E is equal to V by m. And you can apply that value of E in this equation. Instead of capital E, you can use V by L in this equation. Then you will get the equation for drift velocity. This is the equation for drift velocity. In that equation, you have a term for voltage also. So you can bring this voltage to the other side of the equation. You will get a V by V. Okay? You will get a Vd by V. What is Vd by V? Vd by V is the slope. Vd by V is the slope. So what is the slope of this graph? The slope of the graph is E tau by ml. You got it? Slope of the graph is E tau by ml. And which wire is longer? That is the second question. Which wire is longer? Looking at that equation, you will understand there is a relation between slope and length. Slope and length. Slope and length is inversely proportional. This is the slope, and in the equation there is a term for length L. That means slope is inversely proportional to length. If slope is increasing, length will be decreasing. And whose slope is greater? For wire A, the slope is greater. For wire B, the slope is lesser. So slope of A is greater than slope of B. Then length of A will be less than length of B. Did you understand that, Joseph?
Yes, sir.
Okay. Then we will be moving into the next question. What is it? In the next question, question number 21. Question number 21. I will read the question again. The thickness of a conductor continuously decreases from its one end A to another end B. So there is a conductor, and that conductor has a varying thickness. Its thickness is decreasing from the end A to the end B. Its thickness decreases from A to B. And in the question, they are asking what will happen to the electric field, current density, and mobility. What will happen to electric field, current density, and mobility? That is the question. How can we answer this? What will happen to electric field? What will happen to electric field? What is the relation between electric field and area? Is there any relation between electric field and area? That is the question. You have to reach into a relation that is connecting electric field and area. Then only you will be able to answer this question. What is the relation between electric field and area? Is there any equation that you can connect to electric field and area? Any equation that is connecting electric field and area? Do you remember any equation that is connecting electric field and area? Any equation? Can you give me any equation that is connecting electric field and area? Not directly, but we have such an equation. We have such an equation. J is equal to sigma E. Right? We have such an equation. J is equal to sigma E. Now what is J? J is current divided by area. What is J? J will be current density, and current divided by area is the equation for J. Current by area is equal to sigma E. Now what is the equation for E? Equation for E will be, you can bring this sigma to the other side, then that is I divided by sigma A. That is I divided by sigma A. What is I? I is the current. The current through this conductor, will be same. Current will not be changing. Current will change when there is a junction. Right? Current will split and flow when there is a junction. Here there is no junction, so the current will be same. The value of current will be same through this conductor. And now current is same sigma. Sigma is the current density. Sorry, surface charge density. What is it? Surface charge density. Surface charge density is sigma is equal to Q by A. Q by A. Q by A. That's surface charge density. Q by A is surface charge density, right? And let's imagine this surface charge density is same. Surface charge density is same. Okay? And you can simply find the relation between E and area. E is inversely proportional to area. From this equation, E is inversely proportional to area. E is inversely proportional to area. E is inversely proportional to area. As area decreases, electric field will increase. Area decreases, electric field will decrease. Area decreases, electric field will increase. So what will happen to the electric field? The electric field increases. Electric field increases. Electric field increases from A to B. Electric field increases from A to B. Right? Electric field increases as we go from A to B. That's what happens to electric field. Did you understand? Did you understand this? What happens to electric field? Joseph, Jumana, Sidra. Did you understand what will happen to electric field as we going from A to B? Okay. Then let's see current density. Let's see current density. Current density. Current density and area is related with this equation I by A. Current density and area is related with this equation. J is equal to I by A, and I is same. I is not changing. Current is not changing. So I is a constant. That means J is inversely proportional to A. What will happen if A is decreasing? If area is decreasing, current density will be increasing. That means current is a constant along the wire, along the conductor, but the current density is changing. As area is decreasing, current density is increasing. So current density J is increasing. Current density J is increasing as we go from A to B. Current density, the value of current density will be increasing. So that's our second answer. And the third answer, see, what is it? What about the mobility? What about the mobility? What is the equation for mobility? Mobility of a charge carrier is the average drift velocity acquired by that charge carrier in the presence of unit electric field. Do you remember the mobility? Mobility is represented with the letter mu. So what will happen to mobility? Mu has this equation. What is the equation for mobility? E tau by m. E tau by m. This is the equation for mobility. E tau by m. Just look at it. E tau by m. E tau by m. Is there any term that is connecting area with the mobility? No. E is a constant, that's the charge of electron. Tau is relaxation time. And the m. What is m? M is the mass. M is what? M is the mass. Okay? M is the mass. So this is a constant. That means this mobility will not be changing. Mobility of this electron will not be changing. Right? It is not changing. So mobility remains unchanged. Remains unchanged. You got it? You got the answer now? Mobility remains unchanged. Do you guys get it?
Yes, sir.
You okay? Now we can go to the next question. Question number 22. Question number 22. Can I go to the next page? Can I go to the next page, guys?
Yes, sir.
Yeah, okay. Thank you. We are going into the next page. Question number 22, right? Question number 22. Question number 22. The first part of the question. First part of the question. Define the term drift velocity and the relaxation time, giving their physical significance. What is drift velocity and the relaxation time? That's the first part of the question. What is drift velocity? Drift velocity is the average velocity acquired by electrons in the presence of an electric field. We have discussed that many times. That's drift velocity. Then what is relaxation time? Relaxation time. Relaxation time is the average time interval between two successive collisions. There will be collisions, right? There will be collisions of electrons with the positive ions. Two successive collisions. The time interval, the average time interval between two successive collisions is called the relaxation time. That's tau, represented with the letter tau, symbol tau. So that's our first question, and that's a clear theory question. Okay. So the second question. A conductor of length L is connected across a DC source of EMF L. So there is a conductor. There is a conductor and it is having a length L and it is connected to an EMF, a battery of EMF E. A battery of EMF E. If the conductor is replaced by another of the same material, okay? Another of the same material. This conductor is now replaced with another of the same material. The same material means now the conductor is the same material. The conductor is having the same rho. Rho is same in both cases. Material is not changing, then the resistivity is not changing. So the resistivity will be same. Resistivity will be same. And if the conductor is replaced by another of the same material and area of cross section but of length 5L, and area also same. Area of the conductor here and here is also same. But the length has changed. Length has changed to 5L. The first case, the length was L, and in the second case, the length is 5L. The length is 5L. By what factor will the drift velocity change? By what factor will the drift velocity change? That is the question. That actually there is a spelling mistake. By what factor will the drift velocity charge? You can see charge in that question, but it is asking for you to find the factor with which the drift velocity changes. Okay. Now what is here? What is here? You are applying the same electric field, or you are applying the same voltage. You are applying the same voltage. In the question, the conductor only is changing. The conductor only is changing. And let me write the equation for drift velocity in the first case. What will be the equation of drift velocity in the first case? Drift velocity has this equation E by N tau. This is the equation for drift velocity. E by N tau. And now, what is E? E has this equation voltage divided by length. Voltage divided by length. That is the equation for velocity. Equation for E. If I am applying that equation here, then E is E into, instead of capital E, I can write V by L. So V by L, there is M on bottom and into top. This is the equation for drift velocity, right? This is the equation for drift velocity. And from this equation, we can write the equation for our case. What is the equation for our case? Drift velocity is equal to E V tau by M. Here, the length of the conductor is capital L. Here, the length of the conductor is capital L. So this is the equation for drift velocity. And but this case, if I write the equation for drift velocity, E V tau, there is no change in it, divided by M, and instead of capital L, we are using another conductor having 5L length. We are using another conductor having 5 L. Then what happens to it? You can see all these terms represented. So this is the drift velocity has changed, right? Drift velocity has changed. So I can write it as drift velocity VB dash. Now this whole term is what? This whole term is the previous drift velocity, the previous drift velocity. EV by EV top by ML. That's the old drift velocity. Now you can write it like this. New drift velocity will be old drift velocity divided by 5. New drift velocity will be old drift velocity divided by 5. So you can get this relation from the two equations. Okay. Now what is the question? By what factor will the drift velocity change? This is the factor 1 by 5. Drift velocity will change by a factor of 1 by 5. It will decrease by a factor of 1 by 5. So that's our answer. Drift velocity will decrease. Drift velocity will decrease by a factor of drift velocity will decrease by a factor of 1 by 5. 1 by 5. Drift velocity will decrease by a factor of 1 by 5. Is that okay? Did you understand this one? Did you guys understand this one? Joseph, Giovanna, Sidra?
Yes, sir.
Yeah, okay. Then we can move to question number 23. We will do question number 23. Let's see question number 23. Question number 23. Just look at question number 23. 23. Question number 23. What is question number 23? Define the term conductivity of a metallic wire. Write its SI unit. First, you need to define conductivity. Conductivity of a metallic wire. What is conductivity? Conductivity is a property of a material of a conductor, a conducting material. It is represented with this symbol sigma. It is represented with this symbol sigma. What is sigma? You can define conductivity by using the equation of conductivity. What is the equation of conductivity? Sigma is equal to 1 by rho. Right? Then what is conductivity? It is the reciprocal of resistivity. Reciprocal of rho. Rho is resistivity. So reciprocal of resistivity is conductivity. Right? Reciprocal of resistivity is conductivity. What is the unit of it? Unit of conductivity 1 by resistivity as a unit of meter. So 1 by ohm meter, that will be ohm inverse meter inverse. What is ohm inverse? Ohm inverse is Siemens. You can write capital S as a symbol S Siemens per meter. Okay, Siemens per meter. And this is the conductivity. Right? We have discussed many times what is conductivity. So that's conductivity. Then using the concept of the next question number B. Question number B. Let's see question number B. Question number B. What is it? Question number B. Using the concept of free electrons in a conductor, derive the expression for the conductivity of a wire in terms of number density and relaxation time. Hence, obtain the relation between current density and the applied electric field. Read the question. Read that question and understand what it is. Read that question and understand what it is. Did you read the question? Using the concept of free electrons in a conductor, derive the expression for the conductivity of a wire. Derive the expression for the conductivity of a wire. Conductivity of a wire. Conductivity of a wire. In terms of number density, relaxation time, and hence obtain the relation between current density and the applied electric field. Current density and applied electric field. Current density and applied electric field. Applied electric field. Okay, how can we do this one? How can we do this one? That's a derivation. That's a derivation that is connecting number density with what? Number density relaxation time. In the equation of conductivity, we have a simple equation of conductivity. Sigma is equal to 1 by rho. There is no terms of number density and the relaxation time. But we know another equation of conductivity. In that another equation, there was number density and the relaxation time, everything. Charge of electron, all that. And how can we define, how can we derive that? How can we derive that? How can we derive it? From this idea, what is N? N is number density. What is N? N is number density. We have to derive the relation between drift velocity and the electric current first. Okay. So what is number density? Capital N by E. Number of electrons, capital N by V. Number of electrons per unit volume. That's number density. Then number of electrons will be N into V. What is V? V is the volume. Volume will be area into length. So what is area into length? That's area into length. What is length? Length will be equal to drift velocity into time. Velocity into time. This is capital N. Okay. And what is charge? Q. What will be charge? Q. Q is N times E. N times E. So you can multiply it NAVDT into E. Okay. Okay. That's Q. That's Q. Then what is current I? I is Q by T. Charge by time. Charge by time. So what is charge? NAVDT E divided by T. What will happen to this T? What will happen to this T? T is gone from the equation and you will get the equation of current. What is the equation of current? NAVDE. Or I will write it like this. AVDEN. AVDEN. This is the equation for current, right? This is the equation for current. If I write the equation of from the equation of current and bringing this A to the other side, then what will happen? I divided by A. I will get I divided by A. I divided by A is what? I divided by A is VDEN. What is it? That's VDEN. Now I divided by A is current density J. That's current density. Now I have the equation for VD. What is the equation for VD? Minus, and taking that minus EE by M tau. That's the equation. EE by M tau. So I am writing it EE by M tau into what is left there? There is E and N. Okay. If I am multiplying them, that will be N into E into E. N E square tau by M E. N E square tau by M E. And we know another equation that is looking like this equation. We have another equation that is looking like this equation. That's vector form of Ohm's law. What is that? Vector form. From vector form of Ohm's law. From vector form of Ohm's law, you can write this equation. Now, what is the vector form of Ohm's law? That will be J is equal to sigma E. J is equal to sigma E. Right? I am taking this equation as equation number 1 and this equation as equation number 2. Just look at two equations. This is J is equal to some term into E. That's the first equation. This is Ohm's law, vector form of Ohm's law, and that will be J is equal to sigma E. These are two equations and both of them are equal. That means this whole term is equal to sigma. So sigma has this equation. What is sigma? Sigma will be N E square tau by M. Sigma is N E square tau by M. This is the equation for sigma, and this equation is now connecting number density and the relaxation time with the conductivity. Number density and the relaxation time with the conductivity. From where did we start? If we have a conductor like this, and the length of the conductor, length or distance, can write like this: velocity into time. That's distance. Velocity into time is distance. and this conductor is connected to a battery of EMF E. That conductor is connected to a battery of EMF E. So number density, what is number density? N. N is equal to capital N by V, number of electrons per unit volume. What is number of electron? Then N into V. N into, instead of V, you can write A into area into length. Now area into length, this is length, VD into T. Now we have the equation for N. So we are writing N here and we are multiplying that with E. Then you will get the Q, that's charge. If you have charge, you can find current. What is current? Charge by time. Now the time T will be gone from the equation. We have the equation for current. What is the equation for current? ABDEN. That's the equation for current. From that equation, you can find I by A. I by A will be J. I by A will be J. In that equation, there is VD, but VD is E tau EE by N tau. You can write equation of VD here, EE by N tau EN. Then N E square tau by N into E. That's our first equation. That is our first equation. That's our first equation. And from vector form of Ohm's law, you have another equation called J. J is equal to sigma E. That's vector form of Ohm's law. By comparing both of the equations, you will understand that this sigma is equal to N E square tau by N. What is sigma? That's conductivity. Now conductivity is equal to N E square tau by M. You got it? Conductivity now is equal to N E square tau by M. Did you get it? Did you understand that? Yeah, okay. What about you, Jumana, Joseph?
Yes, sir.
Yeah, okay. Jumana? Jumana? Are you there? Are you there, Jumana? Okay. Then, okay. Got it, Jumana. Now I am going to the next section of the questions. That's limitations of Ohm's law. We will do one question from limitations of Ohm's law. That's question number 31. I am skipping some questions in between and I am looking at question number 31. I am going to do question number 31. You two take question number 31. Question number 31 is from limitations of Ohm's law. Limitations of Ohm's law. The question is from limitations of Ohm's law. Question is from limitation of Ohm's law. In the question number 31, you can see a graph showing the variation of current versus voltage for a material, gallium arsenide, is shown in the figure. Identify the region of negative resistance and where Ohm's law is obeyed. That you have to do. Okay. So you have a graph like this. In that graph, on the y-axis you have current, and on the x-axis you have voltage. And the graph is like this. There is such a linear region, and after that the linear region there is a non-linear region. Then there is such a region as like this, which is like this, and this is what? This is the voltage current characteristics of gallium arsenide. This is voltage current graph of gallium arsenide. We know that. And you have to mark, there is some marks. There is B here, there is B here, and C here, and D, and E here. You have A, B, C, D, E. A, B, C, D, E in the graph. A, B, C, D, E in the graph. Just look at the graph. You have A, B, C, D, E. You have A, B, C, D, E. This is B, and this is C. This is D. This is D, and this is E. So you have A, B, C, D, E in the graph. Just looking at the graph and tell me what is negative resistance region. What is the negative resistance region in it? What is negative resistance region in it? What is negative resistance region? Which region is showing negative resistance? Can you tell me which region is showing negative resistance? This is the graph of gallium arsenide. In this graph, which region is showing negative resistance? Which region is showing negative resistance? What is negative resistance? What is negative resistance? As voltage increases, current decreases. That is negative resistance. Right? As voltage increases, current decreases. That is negative resistance. Then tell me which region represents negative resistance? Which region represents negative resistance? Anyone? Joseph, Jumana, Siddha. Which region represents negative resistance? Huh? As voltage increases, current decreases. What is that region?
DE.
Yeah. Which is that region? As voltage increases, current decreases. Which is that region? That region is DE. What is that region? That region is DE. So voltage increases, current decreases. That region is DE. So this DE is negative resistance region. What is DE? That's negative resistance region. Negative resistance region. Negative resistance region. What is negative resistance region? As voltage increases, current will decrease. That's negative resistance region. From the graph, you can clearly see that DE is the DE. The region DE is representing negative resistance region. Okay, that's negative resistance region. And the next part of the question, where Ohm's law is obeyed. Where Ohm's law is obeyed. You have to specify the region where Ohm's law is obeyed. Where Ohm's law is obeyed. That's the second question. You can join after this question.
Yes, sir, can I come?
Yeah. Where Ohm's law is obeyed. Ohm's law is obeyed. Ohm's law is obeyed. Where Ohm's law is obeyed? What is Ohm's law? Ohm's law is voltage is directly proportional to current. As voltage increases, current increases, and which is perpendicular, so which is proportional to each other. From A to C, you can sense that proportionality, right? From A to C, you can see that proportionality. So the region, as voltage increases, I decreases, which is that region? That region is DE. Negative resistance region in this graph is DE, and Ohm's law is obeyed in which part of the graph? From A to C. From A to C, you can see region AC. Region AC. Region AC. Region AC obeys Ohm's law. Because in that region, voltage is directly proportional to current. In that region, voltage is proportional to current. Okay? In that region, voltage is proportional to current. So that region obeys Ohm's law. You can see that that region obeys Ohm's law. You got it? Okay, now look at an MCQ. Look at an MCQ from resistivity of various materials. We are moving to resistivity. The question will be based on resistivity. Question will be based on resistivity, and question number is 31. Question number is 31. Sorry, 32. Question number is 32. Question 32. Read question number 32. The resistance of a metal wire increases with the increasing temperature on account of what? The resistance of a metal wire increases with the increase in temperature. And resistance and temperature. If resistance, temperature increases, resistance increases. Right? Temperature increases, resistance increases. And it is a metal wire also. It is a metal wire also. Did you bring this to previous year question? We are looking at question number 32. Okay. This is your school uniform?
Yeah.
Yeah. Which was the subject today? You are taking moving charges and this.
Well, and this is not chapter like magnetism.
Magnetism is also fiction.
Yeah.
So that's
not
fine.
fiction. It's going to be fiction.
Yeah.
Magnetism, the magnets, or
Question 32. That's a great question. 32. Each number I cannot see current electricity. Current electricity. Question number 32. Yeah. Okay, I will read the question. The resistance of a metal wire increases with the increasing temperature on account of what? That is the question. It's an MCQ. It is an MCQ. The resistance increases with the increase of temperature on account of what? Why resistance increases with the increase of temperature? That is the question. How can we do this? How can we do this? As temperature increases, what happens to resistivity? What happens to resistivity? Resistivity has this equation rho is equal to m by n e square tau. This is the equation for resistivity, right? This is the equation for resistivity. And we know that rho is inversely proportional to n e square tau. N e square tau. And this e is a constant. So rho is inversely proportional to n tau. Rho is inversely proportional to n tau. We know that. What is n? N is number density. What is tau? Tau is relaxation time. Tau is relaxation time. Then just look at it and answer me, which is the correct answer. Decrease in free electron density. If free electron density decreases, what will happen? This will increase, resistance increases. But we are talking about the case of metals. We are talking about the case of metals. In the metals, you cannot change number density. In metals, you cannot change number density. So, what is happening in metal? If temperature increases, relaxation time decreases. In metals, as temperature increases, relaxation time decreases. As temperature increases, relaxation time decreases. If relaxation time decreases, resistivity increases. Right? So that will be the answer. Decrease in free electron density, that's wrong. Decrease in relaxation time, that's right. Right? Decrease in relaxation time. As relaxation time decreases, relaxation time decreases, relaxation time decreases, resistivity increases. Right? That will be our answer. That will be our answer. Okay? What is the option? Option number B. Option number B. Got it? Mark it.
Electron density will be very big.
No. Yeah. In metals, you cannot change electron density. Electron density or number density will be in semiconductors. Semiconductors and insulators. In semiconductors, if the temperature increases, more and more electron hole pairs are produced. If more and more electron hole pairs are produced, if temperature increases, this number density will also be increased. In the case of semiconductors. Okay? You can take that now. Did you understand this one? This MCQ? Number 32. Did you understand this? Guys? Jumana, Joseph, Sidra. Yeah. Okay, Juman. We will take a break at 5:45. Okay. We'll take a break at 5:45. You will understand like if I am writing it like this, right? Okay. Can I move? Okay, then question number next question. It is also another MCQ. What is that? 33. 33. Resistivity of a given conductor depends upon. Resistivity of a given conductor depends upon temperature, length of conductor, area of cross section, shape of the conductor. What is the equation for resistivity? Resistivity as this equation M by N is square tau. So resistivity will depend upon mass, number density, E and tau. Just read the options: temperature, length of conductor, area of cross section, shape of conductor. Which is the factor which is related to resistivity?
That is mass and is.
No, just you have to answer it like this. All these given options are not in the equation. It is not a direct question. It's not a direct question. As temperature increases, as length increases, area increases, shape of the conductor changes, what will happen to resistivity then? From these options, only temperature is depending upon resistivity. Not area of cross section, not length, not shape. Only temperature. So only temperature is depending upon resistivity. Okay. The temperature depends on resistivity. We have studied temperature dependence of resistivity. Temperature depends upon resistivity. Right? As temperature increases, relaxation time will be changed. As temperature increases, relaxation time can be changed in the case of metals.
Temperature and resistivity are
Temperature and resistivity is directly proportional. And in the case of semiconductors, what happens in the case of semiconductors? No. In the case of metals, if temperature increases, collisions are speed up. Collision gets speed up, and then relaxation time decreases. Relaxation time decreases, resistivity increases. In the case of semiconductors, as temperature increases, number density will be increased. If number density increases, resistivity will decrease. If relaxation time decreases, resistivity increases. If N increases, resistivity decreases. But for what? But for semiconductors only. Okay. So what is the factor on which the resistivity depends upon? It is temperature. Resistivity depends upon temperature. Did you get it? Okay. That's our answer. Temperature. Okay. Now look at question number 34. Question number 34. It is another MCQ. Which of the following has negative temperature coefficient of resistivity? Which of the following has negative temperature coefficient of resistivity? What is temperature coefficient of resistivity? Temperature coefficient of resistivity. Temperature coefficient of resistivity, which is the symbol we are using for temperature coefficient of resistivity. That's alpha. What is that symbol? Alpha. Alpha is the temperature coefficient of resistivity. And for metals, what is the sign of alpha? For metals, alpha is positive. And for semiconductors, alpha is negative, right? And for alloys, alpha is nearly zero. Alpha is nearly 0. So what is our option? Which is the correct option? Which of the following has negative temperature coefficient of resistivity? Semiconductors has negative temperature coefficient of resistivity. That will be our answer. Okay. Then look at the next question, 35. That's a one more question, 35. Look at question number 35. Can I move to the next page? Can I move to the next page? Joseph, Jumana, Sidra. Can I move to the next page?
Yes, sir.
Okay. Okay. Okay, next page. Just look at the question. Look at the question. 35. We are discussing question number 35. Question number 35. Question number 35. What is question number 35? The IV characteristics of two wires X and Y at constant temperatures are shown in the figure. Can you see that? The two wires have equal length and diameter. Which of them is made up of material of larger resistivity? Which is made up of material of larger resistivity? That is the question. And you have a graph now. You have a graph now. In that graph, on the y-axis, you have current, and on the x-axis, you have voltage, current and voltage. And two materials is plotted into the graph. That's y and x. Y and x. As you can see, y has greater slope and x has lesser slope. Y has greater slope and x has lesser slope. And what is the question? What is the question? Which of them is made up of material of larger resistivity? Which has larger resistivity? That is the question. Which has larger resistivity? Which has larger resistivity? That is the question. How can we do this? Which has larger resistivity? In the question, they are saying that the two wires have equal length and diameter. They have X and Y. Both of them have equal length and equal diameter. If diameter is equal, area is equal. Right? If diameter is equal, area is equal. So both of them have length and area same. But they are different materials. They are different materials. One has resistivity ρ1, another one has, second one has resistivity ρ2, or ρx and ρy. Ρx and ρy. Both of them have different resistivity, and which has greater resistivity? That is the question. How can we find it? Such a type of questions we can do with the help of slope. Just looking at the graph, if the graph is a straight line, you can use the idea of slope. What is slope in this graph? Slope in this graph will be what? What is slope? Slope is always tan theta, right? Slope is always tan theta or y by x. What is y here? Slope is always y by x. What is y here? What is y? Y here is a value of current divided by what is x here? V, voltage. So that is slope. And what is I by V? No. V by I is R. V by I is R. So what is I by V?
1 by R.
1 by R. That means slope is equal to what? Slope is equal to 1 by R. Slope is equal to 1 by R. And if slope increases, resistance decreases. Right? But you can write from here, slope increases, resistance decreases. Which has greater slope in it? Which has greater slope? No. No, x will be as it goes from like this. This is the increasing slope. This is slope increasing. This is slope decreasing. Okay. So which has greater slope? Y. Slope of y is greater than slope of x. That means resistance of y will be less than resistance of x. Resistance of y will be less than resistance of x.
which has larger resistivity, right?
Yes, which will have larger resistivity. Yeah, resistance of X is larger. Okay, Rx is larger. Rx is larger. So the resistivity of X is larger. Got it? Because L is same, A is same. That's right. Because L and A is same, and Rx is larger. If Rx is larger, that will be made of a material which has larger resistivity. Then only its resistivity, the resistance will be increased. So if Rx is larger, then resistivity of X will be large. You got it? So that's all it is. Resistivity of X is large. Resistivity of X is large. That's just a 1 mark question, right? Nothing to do, just understand the concept of slope. Understanding the concept of slope, you will be able to answer this question. You will be able to answer this question. Okay. After taking the note of this this question, we can take a break. We can take a 10-minute break. After that, we will continue our session. Okay. Joseph, Jumana, Sidra. After you have completed
Yes,
the
sir.
note of this question, you can take a break of 10 minutes. It is almost 5:50, and we will start our session at 6 o'clock. Okay, we will start our session at 6.
Yes.
We will continue. Okay. Okay, Joyita. After taking the note, you can take a break. Right. You need a time to relax, right? Joseph, Jumana, Sidra.
Yes, sir.
Yeah, okay, Jumana. Jumana is okay. Got you. I got it, Jumana. Okay, Jumana, Joseph, Sidra, we will be looking at the next question now. We will be looking at the next question. Sidra, are you here? Sidra?
Yes, sir.
Yeah, okay. Then we will be looking at the next question. What is the next question? 36, right? 36. Question number 36. That's another graph question. 36. Question number 36. Look at the question. In the question IV, that's current voltage graph. IV graph for a metallic wire at two different temperatures, T1 and T2 is as shown in the figure. Which of the two temperatures is lower and why? Which of the two temperatures is lower and why? That is the question. You can use the same method. You can use the same ideas here also. You have a graph of I and B like this. You have I on y-axis, B on x-axis, and you have two materials also. First graph is with the T1. First graph is with the T1, and the second graph is having the lesser slope, and it is with the T2. It is representing T2. Okay. Now, what is slope? What is slope here? Slope is always pi by x. What is slope here? Slope here is current divided by voltage. Current divided by voltage. And what is current divided by voltage? That will be 1 by resistance. 1 by resistance. And now the slope is 1 by resistance. Right? What is the meaning of this? As slope increases, resistance decreases. Right? Slope increases. What is the meaning of this? Slope increases, resistance decreases. That's the meaning. Slope increases, resistance decreases. If slope is increasing, resistance decreases. Right? And whose slope is higher? slope of T1 is greater than slope of T2. Slope of T1 is greater than slope of T2. Okay, so the resistance of T1, slope of it is inversely proportional. So resistance of T1 will be less than resistance of T2 because they are inversely proportional. As slope increases, resistance decreases. So slope of T1 is greater, that means resistance of T1 is lesser. And what is the question? What is the question? Which of the two temperatures is lower and why? Which of the two temperatures is lower and why? Resistance of T1 is lesser, resistance of T2 is greater. And what is the relation between resistance and temperature? What is the relation between resistance and temperature?
Because direct.
Directly proportional. As resistance increases, temperature will be increased. Temperature will be increased. Or temperature is high. When the resistance is high, temperature will be high. And so the T1 will be less than T2. Because our T2 is greater. So T2 will be greater. Which temperature is greater now? T2 will be greater temperature. T2 will be greater temperature. T2 will be greater temperature. You got it?
That is excellent.
This one.
Yeah.
But this one was just for temperature. Sorry, just for resistance only. The slope is greater, resistance will be less. Okay. Okay, it is complete. That question is complete. Can we move to the next question? Sidra? Sidra?
Yes, sir.
Yeah, okay. We are going to the next question. That will be question number 30.
Wait.
Yes.
Question is lower.
Which of the two temperatures is lower and why? Yes. Which is lower temperature? This is lower. Okay. If the question is for lower temperature, then T1 will be the lower temperature, T2 will be the higher temperature. T2 will be the higher temperature. Got it? T2 will be the higher temperature. Okay. Then question number 37. Another graph question. Plot a graph showing the variation of resistivity of a conductor with the temperature. Resistivity of a conductor with the temperature. Resistivity of a conductor or metal. Conductor means metal. Resistivity of metal with the temperature. What will be the shape of the graph? This is the y and x of the graph. This is y-axis. This is x-axis. And for the metals, resistivity and temperature is resistivity. Rho T will be rho 0 into rho 0 plus rho T is equal to what was that equation? Rho T is equal to rho 0 into 1 plus alpha into T minus T0. Rho 0 into, yeah, rho 0 into. Isn't it like this? Rho 0 into 1 plus alpha into T minus T0. Isn't that equation is like this? Right? Rho T is equal to rho 0 into 1 plus alpha into T minus T0, right? It is our equation. So that means as temperature increases, resistivity increases. As temperature increases, resistivity increases. Yeah. And for metals, alpha is positive. For metals, alpha is positive. As temperature increases, resistivity increases, but they are not directly proportional. They are proportional, but not directly proportional. So the graph will be like this. The graph will be like this. This is the graph of resistivity and temperature. Graph of resistivity and temperature for metals. Graph of resistivity and temperature for metals. Resistivity and temperature for metals. Even if the value of temperature is 0, then they will exhibit a resistivity, value of resistivity. Okay. Then question number 38. Question number 38. Show variation of resistivity of copper as a function of temperature in a graph. Variation of resistivity of copper. Resistivity of copper. The same graph goes. It will be the same graph because copper is a conductor. Copper is a conductor, so you can draw the same graph for that. You can draw the same graph for that. Right? You can draw the same graph for that. So that's question number 38. Question number 38. Now question number 39. Plot a graph showing variation of current versus voltage for a material gallium arsenide. For a material gallium arsenide, this is that graph. For a material gallium arsenide, this is the graph. This is the graph of voltage and current. The variation of voltage and current for gallium arsenide. As voltage increases, current increases at first, and then there is a non-linear region. What is this? This is non-linear region. Okay, this is linear region. This is a non-linear region. Then there is a negative resistance region. From this, we can say that this gallium arsenide is not obeying Ohm's law. Up to some point, it roughly obeys Ohm's law, but there is a non-linear region and negative resistance region. This negative resistance region means it is not following Ohm's law. Ohm's law is voltage proportional to current. As the voltage increases, current should increase. But as voltage increases, current decreases means it's a negative resistance region. This is positive resistance. This is positive resistance. As voltage increases, current decreases will be negative. Yeah, this is positive resistance. And in this case, it is negative. So that's our graph. And question number 40. What is question number 40? How does one explain increase in resistivity of a metal with the increase of temperature? How we can explain increase in resistivity? 40. Increase in resistivity. Increase in resistivity. Increase in resistivity with temperature. Increase in resistivity with the temperature. How we can explain this? Increase in resistivity with the temperature. How we can explain this? We have this equation rho is equal to, you can use two equations. This equation is okay. Rho t is equal to rho 0 into 1 plus alpha into t minus t0 is okay. Can use that. No problem. But another equation is there, rho is equal to m divided by n e square tau. There is another equation also. From this equation, you will get this relation, rho is inversely proportional to n e square tau. Rho is inversely proportional to n e square tau. And you can use this equation to explain why resistivity increases with the temperature. Of what? Resistivity of metal. For metal. How you can explain that? We have already discussed that. As temperature increases, what is the first point? Temperature increases. That is the first point. If temperature increases, what will happen to kinetic energy of electrons? Kinetic energy of electrons will increase because temperature. What is kinetic energy? Kinetic energy is average temperature. Temperature is average kinetic energy. Temperature is average kinetic energy of electrons. So the temperature increases, kinetic energy of electrons will increase. Kinetic energy of electrons will increase means collisions are speeding up. If collisions are speeding up, then relaxation time will be decreased. Right? By the equation, if relaxation time decreases, then resistivity increases. Relaxation time decreases, then resistivity increases. Did you understand that? Okay, this is the explanation. How to explain that? How you will explain this? As temperature increases, kinetic energy of the electrons increases, then the collisions are faster. Relaxation time decreases. Relaxation time is inversely proportional to resistivity, so resistivity increases. That will be the explanation. Did you understand that? That's our question number 40. Question number 40. Is that okay? We are just doing these questions to make the concept more clear. Then we will do our worksheet. Our worksheet questions will be more tough than this. Huh? These questions are very simple. You can actually expect such type of questions in exam, in previous exam. These all questions are previously asked questions. Most of the questions are simple, right? But we don't know what type of questions will be coming nowadays after this, because the pattern has changed. More MCQs, less of derivations, less concept questions, less theory questions, more numericals, more MCQs. Okay. And 41. What is 41? Question number 41. Question number 41. Yeah. The graph between resistance R and temperature T for Hg is shown in the figure. Explain the behavior of Hg near 4K. I will draw a graph. What is this graph? This graph is with the resistance and temperature. It is with the resistance and temperature. Resistance and temperature. And the graph looks like this. Graph looks like this. Resistance and temperature. Graph looks like this. And this is at 4K. 4K. 4 Kelvin. 4 Kelvin. It is at 4 Kelvin. 4 Kelvin is a very low temperature. You know that because 0 degrees Celsius is minus 273 Kelvin, 0.15 degrees Celsius. Sorry. 0. That's not true. This is 0 Kelvin. 0 Kelvin. 0 Kelvin will be minus 273.15 degrees Celsius. And 4 Kelvin will be a very low temperature, greater than this, but low temperature. At a very low temperature, this is the plot for Hg. This is the plot for Hg. This is Tc. This is the plot for Hg. What is Hg? What is Hg? Hg is mercury. Hg is mercury. This is mercury. And if you are plotting the resistance and temperature of mercury, you will get this type of graph. What is the meaning of this graph? That is the question. Explain the behavior of Hg near 4K. What happens to Hg near 4K? From this graph, what happens to Hg near 4K? Its resistance drops to 0. Yeah, it is rapidly decreasing and its resistance falls to 0. What is 0 resistance means? 0 resistance. 0 resistance means you can call it now a superconductor. Now the Hg or mercury near 4K behaves as a superconductor. You can write it like that. Mercury near 4K behaves as a superconductor. Why? Because the resistance is 0. Because the resistance drops to 0. Because the resistance drops to 0. The resistance drops to 0. Drops to 0. Resistance drops to 0 at 4K. Resistance drops to 0 at 4K. Resistance drops to 0 at 4K. It behaves like a superconductor. Okay. In which region of the graph shown in the figure? In which region of the graph shown in the figure is the resistance negative and why? We have discussed that many times. In that graph, which is the in which of the region shows negative resistance? We have discussed that many times. What is the negative resistance region? As voltage increases, current decreases. So that region is showing negative resistance.
C, right?
Yeah. Not C. They are asking for a region, so that must be BC. C is a point.
B, C.
Yeah, BC is the region. BC is that region. BC is that region of negative resistance. Okay. Now look at next question. The next question is based on electrical energy and power. Electrical energy and power. Can I move to the next question? Can I move to the next page? Jumana, Sidra, Joseph, can I move to the next page? Okay.
Yes, sir.
Question number 42. Electrical energy and power. The questions are based on electrical energy and power. Electrical energy and power. Electrical energy and power. Question number what? Question number 42. Question number 42. Just look at question number 42 and read it. Question number 42 and read it. What is question number 42? The electric power consumed by a 220 volt 100 watt bulb when operated at 120 volt is what? When operated at 120 volt is what? Electrical power consumed by a 220 volt 100 watt bulb. You have a 220 volt 100 watt bulb. What is this? What is this value? What is this value? This value is called rating of the bulb. What is this? This is the rating of the bulb. Rating of the bulb. From the rating of the bulb, you can find the resistance of the bulb. Right? From the rating of the bulb, you can find the resistance of the bulb. You will get the resistance. Okay. How you will get the resistance? This is voltage and this is power. Which is the equation connecting voltage, power and resistance? Which is the equation connecting voltage, power and resistance? This equation P is equal to V square divided by R. From this equation you can find power. What is power? From this equation you can find resistance. What is resistance? You can bring this R to the other side. Then the equation will be V square divided by P. So what is V square? That's 220 into 220 divided by power. What is power? That's 100. Okay, now this 0 is gone, 0 is gone. 22 into 22. What is 22 into 22? What is it? 484 ohm. That is the resistance. What is the resistance of the bulb now? That's 484. And if this bulb is connected to, this is the rating of the bulb, right? And now this bulb is connected to what? This bulb is connected to 110 volt. Now this bulb is connected to 110 volt. 110 volt. This bulb is not connected to anything now. This is the rating of the bulb. And at present, in the first case, the bulb is not connected to any voltage. But in the second case, the bulb is connected to a voltage of 110 volt. Okay, then the resistance of the bulb is a constant that cannot be changed. That's 484 ohm. What will be the power consumed? That is the question. This is the power rating of the bulb. This is the power rating of the bulb. And now you have to see the power consumed. How you can find the power consumed? With what equation you can find the power consumed? If you are connecting this into a resistor, the voltage, the cell into a resistor, there will be current, right? The current will be flowing through the resistor. The current will be flowing through the bulb. The current will be flowing through the bulb. Okay? And the power consumed has this equation. If there is a current flow, the power consumed will be I squared R. The power consumed will be I squared R because there is a current flow now. Right? So what will be power consumed P? That will be I squared R. I squared R. And I squared R. How can you find this I squared R? Oh no, you don't have to find this I squared R. You don't have to find I because there is voltage and resistance there. There is voltage and resistance there. So you don't have to find this equation. You can use the same equation here also. Power is equal to what? V squared divided by R. We have V and R. Then you can use that same equation. V squared by R. Now V is equal to what? Yeah, 110 into 110. That's our voltage divided by resistance. That's 484. That will be our answer. Okay. What will be the answer? What will be the final answer? I will give you the final answer. I am not doing the calculation. That will be 25 watt. 25 watt. 25 watt will be the power consumed. 25 watt will be the power consumed. 25 watt will be the power consumed. Power consumed. Yeah. What is 11 into 11? 121, right? 121 and 0. 480. That will be okay. 25. That must be 25. There will be some points in it maybe.
There is answer to the.
Yeah, there is an answer 25. I have the answer key here. I have the answer key. From the answer key, the answer must be 25. Okay. Then look at the next question. Yeah. Okay. Then the next question. Can I discuss the next question? Joseph, Jumana, Sidra.
Yes, sir.
Okay. Then I am going to the question 43. Question number 43. What is question number 43? Just read question number 43 and understand it. Two resistors R1 and R2 of 4 ohm and 6 ohm are connected in parallel across a battery. So you have two resistors R1 and R2. You have two resistors R1 and R2, and they are connected parallel to a battery. They are connected parallel to a battery, and the ratio of power dissipated in them, P1 is to P2 will be what? P1 is to P2 is what? That is the question. Voltage is P. What is P1 is to P2? That is the question. No, you cannot use I square R. You cannot use I square R. Why? Because the current through both these resistors will be different. But the voltage in both these resistors will be same. So you can use the next equation, other equation. Power is equal to V square by R will be open. Right? Then what is that? This is R1. R1 has a value. What is the value of R1? R1 has 4 ohm and R2 is 6 ohm. Okay. Then what is P1? P1 will be V square divided by R1. V square divided by R1. What is R1? I am just writing it like that. V square divided by R1. Okay. And what is P2? That will be V square divided by R2 because voltage is same for both of them. And what is P1 is to P2? P1 is to P2 is P1 by P2. Right. So what is P1? That's V square by R1 by V square by R2. Now what will happen with what will happen here? This V square is gone. Right. V square is on the top in both the terms. So V square is gone. R2 will be coming to the top. Should I write the next step?
No, sir.
That's okay. Then that's P2 by P1 by P2. P1 by P2 is equal to, when R2 coming to the form, yes, that will be R2 by R1. What is R2? R2 is 6 ohms, right? So P1 by P2 will be R2 is 6 ohm divided by R1. That's 4 ohm. That means P1 is to P2 will be what? 6 into 4. Yeah. No. If the option is simplified, then you can simplify it. Yeah. Option is simplified. 6 and 4. That will be 3 is to 2. 3 is to 2. That will be our answer. 3 is to 2 will be our answer. We will stop our discussion at the next question. Do you have chemistry after this? Yeah, it's about 6:30. We will discuss one last question. One last question, 44. That's a very simple question. 44. Question 44. Nichrome and copper wires of same length and same radius are connected in series. You have nichrome and copper of same length, same radius. Same length, same radius means same length, same area, same length, same area. Okay, and one is nichrome, the other is copper. And current I is passed through them. Current I is passed through them. Which wire will get heated up more? Justify your answer. Which wire will get heated up more? That is the question. What is the heat? Heat is the energy. Heat is energy. And it is related to power. So which has greater power? Which has greater power? Here I is same. So which is the equation? If I is same, the equation is I square R. And I is same. In both of them. So no, just which is greater R? Which will have greater R? Nichrome, R of nichrome and R of copper. Which will be greater? Resistance of nichrome will be greater because resistivity of nichrome will be greater. Nichrome will have greater resistivity. Right? Nichrome has greater resistivity. Yeah. Then copper, the resistivity of nichrome is greater, so resistance of nichrome will be greater. If resistance of nichrome will be greater, power of nichrome will be greater than power of copper. That means this will consume more power. Nichrome will consume more power. Nichrome consumes more power. Nichrome will consume more power. If nichrome consumes more power, it will heat up more. Yeah. It will heat up more. Did you get it? So that's our answer. Okay, we can wind up our session. In the next session, I hope all the exams in every schools will be completed, will be over.
I told you because she told something about this Thursday.
This Thursday. Then our session will be until Saturday. By Saturday, all the school exams will be over. So we will start we will do the worksheet from current electricity and we will move into chapter moving charges and magnetics. Okay, we will do 2 things in that next session. Okay, see you later.
Sir, during Eid holidays, do you have classes?
I will be here. I will inform you, right?
Yes, sir. Okay, sir.
Okay.
Thank you, sir.
Thank you. See you later.